All right, today we're sharpening your analytical toolkit for the life sciences. We're not just reviewing math here, we're actually building your strategic edge for physics, chemistry, and everything else. Let's dive right in. Now, this right here, this isn't just some nice phrase they threw in the preface of your textbook. I mean, look at the highlighted text. The authors are handing you the master key. They're telling you straight up that math isn't some isolated subject. No, it's the language you use to solve problems in physics, chemistry, biology, you name it. Okay, so what does that actually mean for you when the clock is ticking and you're staring down a really complex problem? It means that if you can master a few core mathematical tools, you get a massive advantage across a bunch of different subjects. Let's take a look at the first one. So, our first tool in the box, the system solver. You gotta stop thinking of linear systems as just a bunch of abstract equations. You need to see them for what they really are. A powerful device for finding very specific answers when you've got multiple variables all tangled up. For instance, take a classic chemistry problem, just like this one. You're asked to figure out the exact composition of some gas mixture. Now, this might look like a chemistry question, but at its heart, it's a math problem in disguise. It's a multivariable puzzle that absolutely requires a system of equations to solve it. This is where your math skills become their science skills. And the most reliable way to crack it is the Gauss method. The whole procedure is it's methodical and it's really powerful. So first, you translate your equations into a matrix, which is basically just a neat little grid of numbers. Second, you use some simple row operations to clean it up, simplifying it into what we call echelon form. Honestly, think of it like tidying a super messy room, until the one thing you're looking for is just sitting right there on top. That's the crucial step, because once it's in that clean form, the answer basically just reveals itself. And this right here, this is the decoder ring. What's so great is how simple this final step is. Once you've got that echelon form, you just look at it. If you see a total contradiction, something impossible like 0 equals 5, you know instantly, bam, there is no solution. If you don't see any contradictions, then you've either got one single answer or an infinite number of them. It's that straightforward. So seriously, you master this one method, and you're equipped to handle these complex systems wherever they decide to pop up. This tool is absolutely fundamental. Let's move on to our next tool and see how this all builds up. Next up, tool number 2. The complex calculator. And you've got to forget about thinking of complex numbers as purely theoretical. For the LS section, you really need to see them as a practical shortcut for some pretty sophisticated calculations, especially in physics. Okay, let's do a super quick refresh on the two key parts. The modulus, that's just its length, its magnitude. How far is the point from the center of the graph? And the argument, that's simply its direction. What angle is it pointing in? It's just like giving directions, right? You need to know how far to go and in what direction. So why does this matter so much? Well, the real power kicks in when you combine them. Using something called de Moivre's formula, you can multiply, divide, and find powers or roots of these numbers so easily. Instead of wrestling with a bunch of crazy algebra, you're just adding angles and multiplying lengths. This is the exact mathematical language behind anything that rotates or oscillates, a huge concept in your physics problems. And that brings us perfectly to our third and final tool, the space navigator. This is all about using vectors to completely master 3D geometry. This is your key to unlocking all that spatial reasoning you need for physics. In this area, you have two critical operations you have to know. First, the vector product. Think of it like this. You put two vectors in, and you get a brand new vector out, one that's perfectly perpendicular to the first two. And its length? That just happens to give you the area of a parallelogram. Then you have the triple scalar product. Here, you put three vectors in, and you get a single number out. That number tells you the volume of the shape they form. And what if that number is 0? Well, that means there's no volume, which tells you all three vectors are lying flat on the same plane. And this shows that connection in action. Just look at this physics diagram for gravitational potential energy. The force of gravity, that's a vector pointing down. The displacement of the object from z1 to z2, that's another vector. And calculating the work done, well, that involves combining these vectors. The math of 3D space is the physics of our world. So here's the bottom line. When a physics problem asks you for the equation of a plane or a line in space, you're not just guessing. You're using these precise vector products to build the exact equation you need. So let's bring it all together now. You have the system solver, the complex calculator, and the space navigator. This whole toolkit, This is your analytical edge.
When you crack open your physics book and you see a problem about forces, you're going to use your space navigator, your vector tools, to model it. When you flip to your chemistry text to balance some crazy equation or figure out a mixture's composition, you're going to reach for your system solver and the Gauss method. And yup, even when you're in biology, analyzing population models, or any system with a bunch of interacting variables, the logic of systems thinking that you mastered in math, that's going to be your guide.
Let's end this where we began, with this really powerful quote from your textbook's authors. This was their goal the whole time, to give you an open and live conception of mathematics. It's alive because you use it.
So please remember this. Linear systems, complex numbers, vectors, these aren't just topics for an exam. They are your tools for analyzing, for modeling, for solving problems. These are the tools that let you think like a scientist.
So the only question left is, are you ready to use them? Go on, build that edge. You've got this. Good luck.